All right, I'm going to go ahead and get started. So good afternoon, everyone, and welcome to our Reduce Plant Downtime webinar. My name is Adrian Lupola, and I'm OneSource Distributor's Information Software Business Development Manager. Before we get started, just a little housekeeping for today's presentation. The presentation is being recorded, and we'll make sure to get a link sent out to you at the end. We'd also like to ask that you please keep all your mics muted for the duration of the presentation. We'll open them up at the very end for a little bit of Q&A. With that being said, we do have chat being monitored by a few of our specialists out there. We have Matt Wright, as well as Sergio Luna on the line, and Bill Harvey and Zach. They're both out. All four of them are out there. So if you feel free to chat in any questions, we'll try to answer them in the chat forum. If not, we'll open it up at the forum at the end and answer them there. So the agenda for today is we're going to talk about FactoryTalk MaintenanceSuite. I'll be handling that presentation. And then we'll be following that up with automatic device configuration by Matt Wright. He's the product manager for industrial controls, sensor, safety products, and functional safety tech. He's a functional safety technician. Then we're going to have intelligent motor control, smart device presentation by Bill Harvey. He's a product manager for industrial controls, sensors, and safety products, also a functional safety technician. And then I'll wrap up with some essential automation services that you might be able to use and leverage to help with downtime. So FactoryTalk. If you were with us last week, I mentioned in our previous presentation that Rock software is specifically built for supporting a full ecosystem of advanced industrial applications, including IoT or Internet of Things. And in today's unique business climate, with our existing supply chain being what it is today, downtime is definitely a struggle. And unplanned downtime is even worse. As your output and plant suffers, expenses usually skyrocket. However, with the right tools like FactoryTalk, you can properly schedule and execute maintenance intervals and also stay ahead of these interruptions that might typically damage your production numbers at your facilities. With that being said, FactoryTalk's MaintenanceSuite gives you key elements to help you manage the most prone areas of your operation, allowing you to predict issues before they occur on assets or network devices using software that they can enhance their security. That can also enhance their security, I mean. Today, I'll be touching base on Rockwell's FactoryTalk AssetCentre, Network Manager, and Analytics for Devices, all part of this portfolio. However, there are also FactoryTalk eMonitor, Team One, which is like a chat function, as well as Rockwell's new Fix CMMS, or Computer Maintenance Management Software. In this slide, some highlights can be seen for the challenges and risks that are associated with an unsecure or unmanaged manufacturing system, and how these risks can adversely affect your production. The first can be seen here is with regards to poor product quality, possibly being due to some changes being made on your plant unintentionally. Infamous Patch Tuesday comes to mind when I think of this. The second is an increase in production scrap or rework when the wrong version of a program or configuration might be downloaded to one of your end devices. There's also the long production delays that are felt when the correct device config cannot be located after you replace the device out in the field. And last but not least, there's also excessive downtime that can be experienced if you're late in your product's life cycle with regards to either being mature, possibly end of life, or even unavailable, and it fails and you have no migration plan in place. I'm sure that the cost of downtime for each of you is different, even with regards to different lines within your facility. As you can see in this slide, whether it's a loss of production, idle employees, damaged equipment, safety concerns, or even increased labor costs, the impact can run from a couple $1,000s through to over $100,000 or even $1 million. So downtime is definitely key for all of us. And this is where Rockwell's FactoryTalk AssetCentre software can come in and help. As I previously mentioned, downtime is bad and unplanned downtime is even worse. An example of this can be seen in the software version updates that are being inadvertently implemented out in your facility, or possibly a harmless fix in one area of your plant that might trigger another risk in another work cell in your facility. Think how easy it would be to deal with these outages if you only knew who did what to trigger the alarm. With FactoryTalk AssetCentre, you can secure access to your most important systems. You can closely track user actions like calibration schedules and certificates, or even firmware versions and updates. You can also gain some added layer of confidence knowing that your updates that are being pushed out are better planned, with fewer opportunities for human error to take place at your facility. As can be seen in this slide, FactoryTalk's AssetCentre has a broad list of capabilities. The first is it can centrally manage versions of programs, files, and folders. It can kick off automated backups, generate detailed difference reports of your assets, and also through the archive and disaster recovery features, it can do all of these in one full software package. There's also the operator track and trace features that allow your users to track their actions, telling who did what, where, and when on your plant, along with the ability to run some ad hoc automated reports that can be sent out via email. For security purposes, it can also restrict the viewing of artifacts, prevent unauthorized access of making changes, or even prevent users from creating new versions of programs out there. It'll also help keep track of Rockwell product life cycles for your plant floor devices and be able to let you compare and detect any changes that might have been deployed to these devices. And last but not least, it gives you the ability to extend and add support for even third-party devices that are not Rockwell, along with giving some access to web clients where you can track asset and devices from mobile devices. So with this slide, when it comes up, why would network management software be used for disaster recovery? The answer to this question is, the reason is the networks that are connecting these automation devices know a lot about performance, especially those elements that might lead to the actual downtime at your facility. FactoryTalk Network Manager provides increased visibility, some insight to the performance of your network, and puts it in context of your automation assets. As you'll see in the upcoming video I have, this software can also help you view your network topology. It can manage your switch level alarms as they happen real time. It can monitor the health of your network as well as reduce downtime to help improve your overall automation equipment efficiency. So I'm going to kick off a quick video.
Welcome to our series covering the capabilities of FactoryTalk Network Manager. In this video, we will take a closer look at how the software can help automation engineers to reduce downtime and improve overall automation equipment efficiency by means of its troubleshooting capabilities. Having the right tools at hand that can collect diagnostic data from devices and present this in a way that is easy to understand and analyze for automation engineers is becoming even more critical in today's automation networks. On the dashboard page, you can view an alarm summary that tells you the distribution of alarms per area and how many alarms there are of each severity. By providing a single network management view for the whole plant, the software helps to correlate alarms and events in real time for multiple devices. This reduces time and effort spent troubleshooting the problem to identify network root cause issues. Many network management systems are limited to SNMP traps for capturing alarm and events, where FactoryTalk Network Manager expands on this capability by also retrieving additional device level ring and PTP time status and fault information via the SIP protocol. By default, this additional status information is updated every 15 minutes to minimize network load. As DLR is single fault tolerant, it is important that network issues are noticed and actioned on to prevent downtime. Alarms are made visible by several indicators on the topology overview, as well as on the other pages. For more details about the alarms, you can either click on the alarm bell icon to see all active alarms, or go to a specific alarm by means of the relevant hot link. In the alarm view, there are several filter options that have been pre-selected to show the alarm you want to investigate. The alarm has not yet been assigned, so let's further investigate by clicking on the timestamp link. This brings us to the alarm details page, where we can find valuable information that tells us more about the alarm, including the fault location. In addition, it also shows other devices that may be affected by this issue. Via the user account profile settings, users may subscribe to email notifications for specific severity of alarms. The email contains a link that will take you directly to this detailed alarm page. When the device has other active alarms, they can easily be accessed to investigate any correlation. In this case, we see that gigabit port 1 is down, which is also causing the ring fault. You can assign a user to the alarm to inform others it is being investigated. For a better understanding of the background, view the history of this type of alarm on this device. And if wanted, you can enter notes for later referencing, which can help in troubleshooting and resolving alarms that are persistent. Further information on the DLR ring can also be found on the detailed switch page, as the static switch in this case is also the DLR supervisor. Here we immediately notice the alarm banner with the current active alarms on the switch, with buttons to go to the alarms page. The DLR tab provides more detailed information on the status of the DLR ring, such as network status and the ring participants, but also the amount of ring fault since power up and last ring fault location. Once we have resolved the issue, we can either manually retrieve the device data or wait for the automatic device update, so the alarm closes without further interaction. Many network issues have their root cause at the physical layer, which includes connector and cable issues, but also auto-negotiate failures which may result in duplex mismatches, like you see here. This can cause various network performance issues that are difficult to identify. FactoryTalk Network Manager detects these errors by capturing SNMP traps of Stratix and Cisco industrial switches, which can then be further investigated. The pre-selected list of most important alarms, relevant to control engineers managing the network, can be found in the alarm settings. They are organized in different categories. And for each alarm and event, you can decide whether you want to monitor it or change the default severity depending on the relevance to your application. Want to know more about FactoryTalk Network Manager? Please check out our other videos available on YouTube or contact your local account team for a demonstration.
All right, so moving on. Yeah, just to get into a little more information about FactoryTalk Network Manager, another tool that we have here, similar to Asset Manager, really going to help out with that downtime, but specifically with regards to networks. The software is a free, no charge download. No activation is required if you've purchased some Rockwell Stratix switches from us. You can download this from the PCDC or Product Compatibility and Download Center site for Rockwell. And right out the box, without paying for any licensing, it's going to give you the ability to discover plant assets or devices. It's going to be able to put up these devices in a topology view or device view. Also going to give you an asset inventory of what you have out there on your plant, as well as the ability to support plug and play. That's that discovery of hardware components within your system without needing any kind of physical intervention from yourself. Also, there's management tools in there like audit trails, role-based access, or AAA support. AAA support is that authentication, authorization, and accounting for security framework or control access on your computer resources. So right out the chute, phenomenal tools. There's also a paid for license. If you do pay for the license, you get the ability to get switch detailed status information like the health, bandwidth, recent activity, or connected devices. Also switch configuration, giving some info on VLAN, speed, duplex mismatches, or the ability to show enabled or disabled ports. There's also switch alarms and events, switch configuration backup, where you can compare or restore some backups, as well as ability to do an upgrade on the firmwares. There's also DLR overlay and statistics for the DLR networks that you might have out there on your plant, backplane bridging, as well as PTP or SIP sync overlay. So a lot of these tools phenomenal right out the chute for free, but you add this license on top and you get these extra features. So the next discussion we'll have is about FactoryTalk Analytics. And in today's day and age, we have several IoT or Internet of Things or industrial Internet of Things out there, from your home appliances, security cameras, maybe doorbells, all the way through devices like I have a Garmin workout watch that I use. These devices out there collect all this data, and they can start to give things such as my watch, not only information about my workouts or what time it is, but also maybe how much water I'm drinking, how my sleep has been. So a lot of extra information based on this data. This is also true when you look at your plant floor. We now see these devices coming up and standardizing on Ethernet IP, which is giving a lot of raw data that from these same end devices, whether it's a PLC or a VFD, some IO out there, and possibly a static switch. Each of these devices can pull that same type of data and start putting it in a context that's much more usable. You can see in this slide, from the left, this is going to be read from the top down, but from the left to the right, there's data, a decision that's got to be made, and some action. So with regards to your system at the very top level, it's going to be descriptive. It's going to start out and try to figure out what happened on your network, some kind of anomaly. The next is diagnostic, where it's going to ask itself, why did this happen? There's still going to be need for a human input before a decision or an action can be taken. But you could see it starts to split the difference. As we start getting into predictive, there's a little less decision necessity to be made on the human side and more on the machine, which it asks itself what will happen. And then prescriptive starts to ask, what should I do if an anomaly comes up? And you could see as we go through down, the end game is really to try to automate this so we can take that human error out, or the need for any kind of human to be in there and manipulate this troubleshooting field. This is another slide that puts it a little more in terms with regards to your plants. So the very bottom, this is meant to be read top down from the enterprise, or bottom up if you're going from device up to the enterprise. But at a device layer, for descriptive, diagnostic, predictive, and prescriptive, it's going to ask, am I running okay? Why did things happen? How do I protect default will happen? Or what action should I do if a fault does happen? We have some solutions out here. The first, which we'll talk about, we'll touch on the device level. It'll go into descriptive and diagnostic and ask, am I running okay? And why did a fault happen? And this can be seen in Rockwell's FactoryTalk analytics for devices. It's going to take all that raw data that's being created out there, like I mentioned earlier, from your end devices, your automation devices, put it through to this agent, the FactoryTalk analytics agent, and apply analytics. Hence, pushing out data for your dashboards that can be really used in the context to help you troubleshoot and isolate any issues you might have at the plant floor. The next we have here is in the predictive area. So this covers both the device and the system layer, asking if the line is having issues and I predict that line 1 quality is moving out of tolerance, it'll give some information and predictive information, as well at the device level. It'll help predict if a fault will happen soon. So getting away from user intervention and start moving a lot more to system intervention. This can be seen in Logix AI, where it actually takes some anomaly detection that's out there, applies virtual sensors and information that you apply to it to actually generate these dashboards that will really be insightful to why an outage might be happening. And just due to limitation of time, once again, there's FactoryTalk Analytics, there's Logix AI, but just be aware throughout the whole portfolio of your issues without in your plan. We have things like Pavilion 8, Plant PAX model predictive control that'll help you out with predictive, prescriptive, all the way from enterprise through to your devices. We have the partnership with PTC. There's ThingWorx Analytics. This will cover everything from your device and enterprise through from descriptive all the way through predictive. And then there's also Dataflow ML. This is going to take your system and enterprise and actually go from descriptive all the way through prescriptive. Then there's Edge ML, or Edge FactoryTalk Analytics, and Edge is going to take everything in your device and system area all the way from descriptive through prescriptive. And then DataView. DataView is going to fill in that gap and give information from device through your enterprise all the way from descriptive to diagnostic. So you can see here there's a lot of helpful software packages out there. Depending what your needs are, please reach out and we can give a little more information. So without further ado, I'm going to turn the mic over to Matt Wright. Matt, we're going to kick off the video and then I'll let you take over. He's going to be talking about automatic device configuration.
Thanks, Adrian.
Hold on one sec. Let me kick your video off.
We get it. You want to spend more time with the family. You want to watch your kids play soccer on the weekends. Not get called in to configure a new drive when your old one fails. You want more of this and less of this. With automatic device configuration, Rockwell Automation helps you work smarter so that the world works better. Now, anyone on your team can configure that drive in a few simple steps so that you can spend less time feeling like this and more time feeling like this.
Okay, that was a nice little video that just quickly kind of shows you how this automatic device configuration can help save a lot of time. And I'm going to go through it in a little more detail. So you can see from this slide. So let me just start off by automatic device configuration is a feature in Logix that allows you to replace certain PowerFlex drives and not have to go in and configure those drives as you typically would have to do in the past. So this feature works with just a few of the PowerFlex drives, including the PowerFlex 753 firmware version 7.002 and later, PowerFlex 755 drives, firmware version 4.002 and later, all the PowerFlex 755 T drives, the TL, the TR, and the TM. It works with all the PowerFlex 525 drives, the 523s, all firmware versions, and also the PowerFlex 6000T medium voltage drive. This feature you have to use at a minimum RSLogix 5000 version 20 or version 21 of Studio 5000 and later. So anywhere from version 21 to the current version 34, this feature is available. So how the feature works is that in the controller, in the drives property that's been configured, you have to enable the feature. There's just a checkbox that you click to enables ADC. The drives have to be connected to the controller over Ethernet. So Adrian, go ahead and click the next slide. Okay, so in here you see a compact logic controller. There's a static switch. You have 3 PowerFlex drives. So everything's running fine. Go ahead and click the next action. So there's an issue with this middle drive. So the drive has actually failed. It's more than just faulted. It has a hardware failure. It needs to be replaced, right? Go ahead next. So when you have this ADC feature enabled, you'd remove the old drive. Next. Install the new drive. And depending on how the system is set up, if you're using a static managed switch and you have it set up for IP persistence, so where it actually, the drive will be set for DHCP, where the switch will automatically assign the IP address to that, from that particular port to the drive. You don't need to configure an IP address manually if you have a managed switch. The second thing is the controller is going to look at the firmware of the drive. So the firmware of the drive has to match the firmware that's set up in the controller. And if it's not, you can set up the firmware supervisor in the controller and load the firmware file of the drive in the SD card. And with the firmware supervisor will automatically flash the drive with the firmware that is loaded in the SD card. So let's say that this drive was firmware originally configured for firmware 6, but you purchase a new drive that happens to be version 7 and install it. Well, the ADC feature in the controller has to be, the keying has to be set for exact match. So the drive has to have the same firmware. But with the firmware supervisor, you don't have to. The drive could be a higher or lower firmware, and when it's connected and it starts communicating, it will automatically flash the firmware that's installed in the SD card to the drive. And then once that's accomplished, the the controller will then look at the checksum value of the drive, which is basically a value based on how the parameters are currently set in the drive, and it will match that to the configuration checksum in the controller. And if they do not match, then the controller knows that there's some differences, and it will automatically download the configuration into the drive. And once that's accomplished, then the drive is ready to run, and you're back into shape. So, a lot of people that have replaced drives in the past in different facilities, there's the biggest issue is, do they have a backup of the parameter settings for that particular drive? I mean, in most plants, there could be anywhere from 10 to hundreds of drives in that facility, and each drive can have a different configuration. So, keeping an archive of those settings, whether it's written down or you did created a file with CCW, Connected Components Workbench, or Drive Executive, and saved that file with the configuration. Getting that data and having that data on hand sometimes doesn't happen. And so when that drive fails and the technicians replacing the drive, they're not sure how those settings need to be set, right? And it's almost a trial and error. In some applications, those parameters could be very specific for that application. So when the controller is configured with the parameters, they're always the same. When you enable ADC, you're unable to make changes manually on the HIM module of the drive. So that kind of ensures that nobody can tamper with the settings. They actually have to make changes in the controller itself. So there's a lot of great benefits from the ADC. Now, if you don't have a managed switch, the minimum requirement is that you're manually going to have to set that IP address in the drive when you replace it, which typically in that scenario, the procedure would be is to remove the old drive, install the new drive, wire the power, incoming power, and motor connections, power the drive through the HIM module, or using one of the drive softwares like Connected Components or Drive Executive, set the IP address of the drive. Then you must cycle power for that change to take effect. And then once it does, then the download process can continue. So how am I doing on time, Adrian?
Yeah, you got about 2 minutes, 2.5 minutes
Okay.
left. Yep.
Yeah,
Still got a
so
little bit.
this slide is basically shows the three portions of a full automatic device configuration. So like I had talked about, the DHC port persistence, if you want to replace that drive without having to manually set the IP address, then you would utilize this DHC port persistence in a Stratix switch. The second part is the firmware supervisor, right? So if you don't have to worry about manually flashing a firmware to match what's in the controller, then you can utilize the firmware supervisor feature in the controller. It's very simple. You just go ahead and you can see down here where you store the firmware file into the SD card, and then there's a couple settings on this page that you use to enable it to flash the firmware. And then third is, making sure that you enable the automatic device configuration in the drive properties page. So this is definitely, Adrian had talked about analytics, which is more of a prescriptive type approach to reducing downtime. This is where when a device fails, you're reducing the amount of time it takes to replace a component to get back up and running. And you can see by this that there's a lot of time saved, because basically, if this is all set up correctly, you should be able to replace a drive within minutes as long as you have a drive on hand. Just removing the old drive, powering down, removing the old drive, installing the new drive, connecting the Ethernet, and let the controller do the rest. So that's all I've got for this presentation. Thanks for listening.
Awesome. Thanks, Matt. Next up, we have Bill Harvey. He's a product manager for industrial controls, sensors, and safety products, also our functional safety technician. Bill, you want to go ahead and take over?
I am here for a small nominal fee. Yes. Okay. They talked a lot of nice fancy software and firmware and good things and stuff, but what we're talking about here is they've gone down to intelligent devices, smart manufacturing, smart machines. So now you're down to the device part where the rubber meets the road, right? So what are the devices that talk to all that fancy software and get you the data? So I'm just going to go through a couple of them since we only got a few minutes. Quick blast. One under intelligent motor control. Oh, first, of course, you got drives that fit in there on the line. There are also soft starts that have the communications in there, can put you on a network and get you tons of data upstream there so you can take care of that. So again, we're talking about predictive and preventive maintenance as opposed to reactive, because this is a seminar here about plant downtime. So if we can prevent the thing from happening in the first place, you're not stuck with that. And then also maybe we'll show you how we can have you have the right parts on the shelf, for backup inventory and stuff with the supply chain issues. So drives, then soft starts are big. Then not only for regular, all your dumb motors out there, right? But some are more critical than others. So we see a lot, especially like water, wastewater, and bigger industries where you got a lot of big motors. We can add an E300 overload. So this is a smart overload. We can hook it on DeviceNet or Ethernet, and some other things too. But in this, if you go to next, we also add that automatic device configuration. But we build this, if you look down on the lower right there, into our motor control centers, right? We can get this E300 and what we call our IntelliCenter MCCs, so we can get you all the data, the motor data, back up through the stuff. So I can do it on discrete, out there on pump panels or remotely, or in an MCC or any control panel. But we have smart motor control here, right? So if you go to the next slide here real quick. So again, this can be done on any motor, basically. We have some panel mount versions, so it doesn't even necessarily have to be an Allen Bradley starter in there. Or we have into our 100C and our now 100E IEC contactors, we can add the smart overload. The Bulletin 300 is a NEMA, kind of like the IEC starter with a NEMA label there that covers the NEMA for lower cost NEMA requirements. And then over on the far right, you see like our big 509 starters, our full-blown NEMA contactors and starters. But we can put these devices, so either as a standalone panel mount with the little stabs to go into IEC contactors, or the stabs that go up into the NEMA contactors. So they fit all three types. Next slide. And what's nice with this, you can set this up also over, these things have a built-in little web thing, so that you can actually do it over a web browser, right, to set this up. But on the E300 overload, there's almost 400 parameters you can set and play with. And depending on what you hook onto, there's also optional IO and some voltage modules and stuff you can. We can actually look at voltage, current, energy, kW, kVAR, kilowatts, all kinds of good stuff. But the nice thing is you get trip and warning history. So, and you're looking at the thermal capacity of the motor. When you have like your old-fashioned starters that had overloads, right, you're looking at the heat in the windings, right? So this can actually model that and keep track of motor winding temperature. You can actually, if you have thermistors in the windings, you can have those attached to this too, and look at your motor windings. But you can see how the motor's running, and if things start to get, you set parameters. So if it starts to run, maybe like a conveyor is getting overloaded, or a mixer, the batter, the dough is getting too thick or something like that, whatever, the current's going to start to creep up. But I don't want to wait till I snap a shaft or something breaks or it just stops. So you can set, pre-warning. So as things start to get up, maybe if it's an in-feed conveyor, it has to back off a little bit so the load on the conveyor doesn't get too strong and stuff like that. So you can do some logic in this and control what's going on. But again, also do something before it shuts down. Then you still go to the point where, if it shuts down, you're going to see that over a network. You can send, emails and texts and all kinds of stuff out to people to get people on it. This is especially critical in, the more remote applications. If somebody's not sitting there watching it, the more advanced notice you have, the less downtime you're going to have. But you can monitor a ton of parameters in the thing and set it all up. So next slide. And okay, that was the really quick thing on the E300s and those. We're also, the other part of this equation is IO Link is another device level thing. It's a took over after DeviceNet, right? So DeviceNet was an IO Link or a device level thing. So IO Link, it's an open standard. Every sensor manufacturer and valve manufacturer and stuff out there makes stuff. But when you see that little symbol, the little up and down carrots there with IO-Link, I get a lot of data. So over 4 wires, I have to go through what's called an IO-Link master. This is a point IO version. It's, in cabinet. There's also an armor block on machine version. You'll see it in another slide. But over the standard 4-conductor cable that you hook to all these sensors, and a lot of our standard inductive photo eye proc sensors, it's the same sensor. If you hook it up as a dumb sensor, you just get the on and off status or maybe an analog value out. But if I go over IO Link, I get sensor health. You can turn things into like counters and timers built into this. Again, you can get margin indication and a lot of diagnostics of what's going on with the sensor. Again, if a photo eye is starting to get dirty, or there's like a warning on the proxies if the head gets sheared off, or again, a margin indicator if things are starting to drift and things are getting too close where it may cause damage, you can set those parameters up. And before something bad happens, you can get out there and adjust it and fix it and do something to it, right? But what's nice, it's all over the same simple 4 wires you're doing anyways. You just have to go to this IO master, that in turn back up to, through Ethernet IP to your controller. And again, you can see all that data on your HMI screens. You can go up to those higher level softwares and do fun stuff with that. So that's all good there. Next slide. And here you go. So again, this is automatic device configuration. This is the sensor equivalent to the automatic thing that Matt talked about. So again, if I have a sensor and I take off the sensor goes bad, forklift hits a photo eye out there and a thing. One, all that information about what that sensor is, because a lot of times, little proc sensors and photo eyes, they get out there, they get dirty, they get gunk on them. You can't see the labels and stuff. But I don't care, right? Because all that information again is back in the controller, right? You can do tags in your controller that says, photo eye number 3 or exit conveyor, photo eye, whatever it's going to be there. So you name the devices, you can see the health of them. And then on like these photo eyes and stuff, you can also say it's a long conveyor line and one's starting to get out of margin. You can have it flash like a locator thing, right? So you tell the guy, just go out and adjust the one that's blinking at you. So he doesn't have to think which one it is. He goes out there and he can see that and it's telling him, hey, I need help. I'm the guy you're looking for here, right? Because a lot of times sensors and stuff are buried in a machine. You don't know where they're at. They'll blink at you so the operator can actually see what's going on. But again, no special skill required. The operators can do it. You don't need to get an electrician out there to rewire something to do it. The operator can take it off, put another one in. It's the same thing. All the parameters for that device, the margin adjustment for the sensors. If you're doing color sensors, the little color parameters you had set in there. Pressure stuff, that's all in the device. It gets downloaded right back to the device. So again, guy unplugs one, plugs another one back in. The controller loads up the information. He's back off and running again, right? So again, we're eliminating downtime. So that was a good quickie thing on IO Link. All right. Next. And again, what's nice, like I say, IO Link it's global. There's a lot of manufacturers that have it, but when you do the Rockwell version, we give you this add-on profiles and these faceplates that go with our Logix 5000 and this IO file. Here's a data file that goes with it. But what's nice is when I plug in an Allen Bradley sensor and it gets on the network right in my Logix software, I get to see all the parameters and settings and the things, and they're labeled for you, right? You can take somebody else's sensor and plug in there, but then you have to do the mapping. What does that bit mean? Is that telling me margin? Is it telling me on, off? What is it? So you have to map all that data. When I hook it into the Allen Bradley with the add-on profile, all that information comes up with the sensor. There's also even a thing that tells you the part, the serial number, the date of it. And again, that goes back into that, like the fix software or whatever, your maintenance management software. So you have a history of all those parts, what they are, where they are, what's going on, right? So we do a lot of that. And again, this is showing the IO block or the armor block IO version. And there's the point IO master, but all those devices get hooked into the master. But there's a ton of data on these sensors. So another nice thing, like some sensors, you get the on off, but it can actually even emulate like digitally. Instead of a 4 to 20 milliamp analog signal, I get a digital reference back that's even, it's more robust and it's not sensitive to noise, like a 4 to 20 milli analog signal is. So I can get analog functionality out of a digital sensor and not worry about issues. So keep going. Next. And then this is just a nice little, oh, GuardLink. Okay, GuardLink is one of our other smart um, networks to deal with. So this is basically the safety version of IO-Link. So what you're seeing here on the left, again, there's your controller and enterprise stuff. All the green is Ethernet IP. So in safety, I've got some smart door interlocks, our 440G, the MAB, multifunction access box. You see light curtains and the laser scanners. Those have Ethernet ports on them. So those are directly tied to the Ethernet and get up there. So again, I get all that information back. And then what else are we doing? And then you see over here on the left is GuardLink, similar to IO-Link. I have a GuardLink master. And again, through a series of taps and things, I can turn on all these devices. I get some diagnostics over the same 4 wires. So it simplifies my wiring for interlocks and e-stops and interlock switches and my cable pull switches. But again, simplifies the wiring. I get diagnostics. I don't worry about fault masking and some other good things with that. And then what you're seeing here is like that the far right where the guy's got the question mark, whole bunch of doors there, right? But maybe one interlock is messed up. The old days, people used to go and open all the doors to figure out what's going on. Now I get that information back on my HMI. It tells me what door is open, where it is. I can go fix it, adjust it. I'm back up and running again. And if I have to change a device, again, unplug it, plug it back in. It's right back online again. Next. I know
Hey,
we're
Bill,
running
we're
for
getting a
time here.
little short on time, so
Yeah, so this
yeah.
this is just another, it's not part of Rockwell, but again, we're talking plant downtime. The biggest thing is having qualified people out there that know what they're doing. And then you see over here, reduce PPE, but people are worried about, arc flash and safety, right? So a lot of you are familiar with the Grace ports where I can do receptacles and have Ethernet ports, but this way I can access the machine and the PLC without having to put on the bunny suit and get all suited up. So again, I can get into the machine, see what's going on without having to open the cabinets, expose it to dust and crap, or and keep people out of it and not get in the way. Next slide. And then the other part of this is, again, downtime. Lockout, tagout can be an onerous process where you guys have to put the bunny suit on. They're supposed to put the meters inside, verify the absence of voltage and stuff. So we have these voltage indicators here. This is just on off, typically on like disconnect switches, so I can see that there's power coming to a switch, or it also works as like blown fuse indicator and stuff on the outside for mechanical lockout tagout. This voltage test station, I have the voltage indicators to see the lights, and then outside the panel, I have a place to put my meter probes, again, to check for absence of voltage. So again, I can take a half-hour lockout tagout procedure and do it in under 5 minutes without having to put the bunny suits on to go in the panel and do it correctly. All right, next slide. And this is just an application just showing some on the door. So again, you see up at the top there, a voltage indicator. That tells me I have line voltage coming in, right? They also put one down below. If that's a fusible disconnect, that also acts as like a blown fuse indicator. So, switch is on, both of those things should be lit up. If I turn the disconnect off, I'll see lights on the top. That lets the guy know there's live voltage up there coming into the panel. Down the bottom, the switch is off. Or again, if I blew a fuse, I'd see 2 of the legs are still hot. One, the thing is off. I know what's going on. Right below that is the voltage test station where I can put the probes in and test stuff, right, and do stuff. So you can do a lot of verification without having to open the panel and have people put the suits on and stuff. So that was the quickie application about downtime. Pretty good,
Awesome.
Huh? Good.
All right, so we're a little short on time, so I'm gonna just to be aware, we do have some services here at Rockwell, some Rockwell and OneSource, some essential services, whether delivered by Rockwell or OneSource. You can look at 24/7, 8x5 self-assist technical support, equipment repair services. We have Rockwell equipment audits, field engineering labor, training services. On the authorized service provider wing, we have the industrial network assessments that I can assist with. Also security posture surveys, leak detection audits, as well as drive startup services. So all of these different, I guess, subjects that we talked about today can be used to help you out with limiting your downtime. So without further ado, we'll go ahead and kick off some questions. Are there any questions in the chat? I'll take that as no. So if there are any questions, please feel free to unmute let us know. If not, you can get a hold of us afterwards. Feel free to reach out to me. I'm Adrian Lupola. You could reach out to your account manager, any of our different product managers. We'd be happy to assist or give you more information on any of this content.
Hey, Adrian, can I just share my screen just a sec? Just show the Rockwell site where they can find some of this info.
Sure. Go for it.
Okay, boom, do this. And then I will blow this up right here. So if you just go to ab.com, right, it takes you to rockwellautomation.com. So right on their main ab.com webpage, if you just scroll down, and you have to do that a lot on these pages, but Ready to Get Smart, and some new product stuff here they do too. But right here is a whole thing about smart devices and smart manufacturing. So smart machines, smart devices, smart systems. So there's there's videos and a lot of literature here of how we get smart and smart safety, and also you get into SIP security, but there's a lot of good information here in videos that you keep going down. And this ebook here of smart manufacturing, and more webinars. There's a Rockwell webinar on this stuff. I talked about smart motor control, smart safety, smart sensors. So you can do a more deep dive on those products, and some other good things, right? So there's all the logic, the motion, the controllers, the drives, and how they're all tied together. And this, again, some of the about not having downtime. So it's the little videos that kind of explain what we did of, how you get the health and the diagnostics, what's going on with the sensors. Some good little videos here to explain what we just went through about eliminating downtime. So there's like 3 or 4 minutes of videos explains what we just did. All right, that was it.
Awesome. Thanks, Bill. Thanks, Matt, for your assistance today. Really appreciate the content. Once again,
Hey, Adrian,
we're here to
there's a
assist.
question in the chat from, this is
Oh,
probably
yeah.
for Bill from Tongno. He goes, where can I find those connector plates with all the different cabinet connectors?
Connector. Oh, the Graceport ones?
Yeah, I think that's what he's referring
Yeah,
to.
okay. Here, that's Grace Engineering. So wait, let me share my screen again here. That's really, uh and we stock some. I've got one of that voltage port thing in my car. So wait, I gotta do it here. There we go. So that is just if you just want to do your basic thing here, I just go Grace Engineered Products right there. And then we'll see this. That didn't do, oh, they changed things around a little bit here. Go here. Come on. There we go. So Grace Technologies, they changed their name. Use Graceport and stuff, but there's several different things, right? So Grace ports are those port things you talked about. The PESDs is the permanently installed electrical safety devices. Grace Sense is another more thing. That's another whole part where you start getting into with the IoT, and we have smart like vibration monitors and temperature sensors that go over Bluetooth. And we can do some fun stuff there, right? So this is they are a partner product with Rockwell, but there's the Grace ports. They've also got, again, about downtime, they got some really cool covers to go over your HMIs so they don't get all beat up and exposed to stuff, and they're UV resistant, like for outdoors, to protect your HMI screens. And then here is the Grace PESD. So that's that voltage port. And there's a whole bunch of download more and learn the data sheet. So it's graceport.com is where you're at there. We'll
Well,
do
what
all
we can
that.
do afterwards, Bill, is get me some links to that information, and when I send out the link to this presentation, I'll include all that information.
Oh, okay. Well, here it's that one right there. I'll copy that sucker. But yeah,
Awesome.
they're
Great.
good. They're good with
Perfect.
that.
You could
And
also
then
put it into the chat if you want to insert it in the chat, and they could get it that way. But I'll
where's that
also make
magical
sure to
chat
send it
there?
out at the end. Include it. Please send it off to me, and I'll include it in the video link.
Okay, cool. All right.
Awesome.
Very good.
Any other questions out there?
I think we're good, Adrian.
Awesome. Thanks again,
There.
guys. Really
It's in the
appreciate
chat,
your
Twan,
support.
so there you go.
Yep. And thanks everyone
Thanks,
that's
Bill.
on the line. Please reach out. Let us know how we can help you out. Have a good rest of your day.